Hi, thank you for clicking on my video. And if it's for the first time watching my videos, please make sure that you do subscribe, and that way you'll be helping the channel to grow. And kindly don't forget to enable the notification bell so that every time I do upload a new video, you'll be able to see it. In today's video, I'm going to talk about number patterns sequence. I'll also be covering grade 11 revision on quadratic sequences and deep dive on the arithmetic and geometric sequences. To kickstart our lesson today, let's start by the definition of a quadratic sequence. A quadratic sequence is a sequence in which the second difference, right? Second difference. So let me explain what a difference is in the number patterns. To help me explain that, I'm going to use an example. Say you have a number pattern 4, 7, 14, and 25, right? So a difference is a result of a substitution operation, right? What do I mean by that? So you say 7 minus 4, that will give you a 3. A 3 is a difference. Now let's continue. 14 minus 7, that will give you a 7. And then 25 minus 14, that will give you 11, right? Now, this will be the first difference, all right? Going back to the definition, a quadratic sequence is a sequence in which the second difference, not the first difference, right? And how do you get to the second difference? You continue from the first difference. You actually do the same thing. 7 minus 3, that will give you 4. And then 11 minus 7, that will also give you a 4. This is now our second difference. All right. I hope you're still with me. Going back to what the definition says, a quadratic sequence is a sequence in which the second difference, well, we do have a second difference here, right? If the second difference is the same, therefore we have a quadratic sequence. You go look here, we have got a 4 and a 4. These numbers are the same. Therefore, this means therefore we have a quadratic sequence. All right. Going on. Let's continue. This is the general nth equation, right? And I'm going to try explain what each letter or variable means, right? So let's talk about what n means in this equation, all right? So n means the position of the term. This is term 1, 2, 3, 4. So let me say if you have term 1, right, which is 4, therefore n will be 1, right? Which simply means t is the term and 1 is the position that term is occupying, right? So position 1 is occupied by the number 4. That is why T1 is equals to 4, right? Now, let's do the same to the rest of the terms. T2, which will be equals to 7, therefore, n will be equals to 2, right? That 2. And doing the same to the rest of the terms, T3 equals to 14. Therefore, n equals to 3. The last part will be T4, which is equals to 25. Therefore, n equals to 4. All right, I hope that is clear. Now let's try to explain what A means in this equation, right? A means a constant term that is equal to half of the second difference. Now, we know what the second difference number is. Well, we have A, which is equals to the second difference, which is equals to 4, right? Second difference is number 4. Second difference divided by 2, right? So the answer will be 2. Moving on to the next part, B and C. B and C in this case are just constants, right? Constant terms. So to get the value of B and C, we will use this. You can choose any two to get the two equations and solve them simultaneously, right? Let me show you how to get the two equations, right? So from this equation, we already know that a equals to 2. So I'm just going to substitute it here, right? So we have 2n squared plus bn plus c, all right? So let's start with that part. So if t1 equals to 4, I'm going to say t1 equals to 4, therefore n equals to 1, okay? So wherever I see n, I'll put 1 because t1 equals to 4, all right? So this simplified will give me, say, this will be 2 times 1, which is 2. 2 crossing over to the other side will be minus 2. So 4 minus 2 equals to 2. B times 1, that is B plus C. This is my first equation, right? Now, I'm going to do the same with the second part, right? I can choose any, but I'm just going to choose this one because this number is easy to work with. It's a small number, right? So this is 14, this is 7, yeah. But you can actually choose any number. And so if T2 equals to 7, right? 7, so remember I'm using that. If T2 equals to 7, therefore n equals to 2. Right. So wherever I see n, I put 2. Well, this simplified will be, okay, 4 times 2, which is 8. 8 crossing over to the other side, minus 8, plus 7 minus 1. B times 2, 2b, plus c. This will be my equation number 2. Let's take these two equations and try to solve them simultaneously. If I have on one equation and on the other I have the same constants or variables, like say variables with the coefficients that are the same and the operations, sign operations are actually the same, therefore I can substitute or can make it the subject of their formula. But for this operation or this method, just make sure that the order of these two equations are the same, right? So it's a number and a number, equal sign, equal sign. The variables must be aligned, right? Doesn't matter what is in front. And therefore, that these two signs, okay, in this case, and given what I want to do with this equations, these two signs must be the same, and there's the last variables as well, or these two variables must also be the same, right? Exactly the same. Yeah. So I'm going to say equation 2 minus equation 1, right? The aim is to cancel these two, right? Because they're exactly the same, right? Think about it. If it's 1 and a 1, so and I say equation 1 minus equation 2, that will mean 1 minus 1, that is 0, right? So I'm just trying to cancel these two variables. Therefore, I'll be only left with variable b. So equation 2 minus equation 1. Minus 1 minus that minus equation 2, equation 1, sorry. And then equation 2, right, minus equation 1. Equation 2 minus equation 1, right? This simplified minus 3. There's 2b minus b. This is b. C minus c, 0, right? Therefore, b equals to minus 3, right? I can call this equation 3. Let's sub equation 3 into equation 1, right? This will be 2, then what is b? Minus 3 plus c, that is minus 3, that is b. This crossing over to the other side will be 3 plus 5, which is 3 plus 2, which will be 5. Therefore, c equals to 5, right? The result will be Tn. Now we know all the variables, right? Tn will be 2n squared. What is b? B is minus 3, and then c is plus 5, right? All right, so the last part will be just to prove if we did the right thing. So this is my general nth term. So I want to prove if this is correct, right? So remember, this is term 1, T1, which is equal to 4, right? So if I say T1, remember what I said. If it's T1, this is n plus 2, that 1, right? So wherever I see n, I'll put 1, okay? So this is 2 minus 3 plus 5. 2 minus 3, that is minus 1, plus 5, that is 4, okay? So this is correct. Now let's do the other part. T2, right? So if it's T2, where I see n, because it's T2, I'll put 2, right? I'm using this equation. Where I see n, I'll put 2. All right. This is 4 times 2, which is 8. This is 6. This is 5, right? How do you want to go about it? So this will give me 7. Why? So this 8 minus 6 will give me 2. 2 plus 5 will give me 7, right?